Okay, here what we're going to do is we're going to discuss how there is a connection between the numbers in Pascal's triangle and combinations, NCR. And then we're going to look at something called the binomial theorem. Okay, so a quick recap. Remember how I keep saying everything starts with 0 for Pascal's triangle? The first row represents the expansion, the coefficient in the expansion of 1 plus x to the power of 0. So it starts from 0, and we said n equals 0, then it went n equal 1, and n equal 2, and so forth. And remember, the easy way is look at the second number that tells you the n. It turns out that these numbers here are in fact just NCR. Okay, now, really important, n equals 0 represents the first row, n equal 1, second row, and so forth. So this top number here, so this 1 here is the same as 0C0. And remember, another way of writing combinations is rather than using the C, sometimes you use brackets and put the N number in the top and the R number down the bottom. Okay, that's what this represents here. Notice that every single one on this diagonal down here, the R value is 0. So we start counting from 0, both for the row number starts from n equals 0, and also the position within that row, which is given by the R, starts from R equals 0. Okay, so just be aware of everything starting from 0. So for example, let's imagine this term here. Well, this is the n equal 5 row. We start from r equals 0, 1, r equal to 2. This number 10 would be 5c2, okay? That one there. All right. We will discuss why Pascal's triangle ends up, the coefficients just end up being NCR in a moment. So this means that rather than like just me saying to you that we write Pascal's triangle, we can now write our expansions as a formula, and this will eventually lead to the binomial theorem. So let's imagine we're going back to 1 plus x to the n here. Okay, remember the powers of x go up, and the coefficients will now be given by nc0, nc1, nc2, and so forth. Okay, this is quite a long expansion. We have a way of writing it shorter using something called sigma notation. Okay, sigma notation uses the Greek letter sigma, and the Greek letter sigma is used for a sum. Okay, so this sigma from r equals 0 to r equal n, that's how we would say that. That means we're summing all these terms here starting from r equals 0, and then you increase by 1 every time, all the way up to r equal n. So the r equals 0 will give you this first term, the r equal 1 will give you the second term, r equal 2 and so forth, all the way up to r equal n, which will give you the last term. So basically, sigma notation is just a very, very short way of writing out this long sum. Okay, often the way it's written is what we call the rth plus 1 term. Okay, which is given by this expression for 1 plus x to the n, ncr x to the r. Okay, why is it written with a r plus 1? Well, this would be the first term, I'm going to call that t1. This would be the second term, I'd call that t2. This would be the third term, t3. Can you see that for each of these t's, the sub value is 1 higher than the power and 1 higher than this r value here. So 1 higher than the r value, hence why we put an r plus 1. Okay, it should be noted that we go from r equals 0 all the way up to r equal n. Okay, and that's your n plus 1 terms in your expansion. Okay, because we're going from 0 through to n. All right, so let's do a couple of examples so we can practice. So write the expansion of 1 plus x squared and 1 plus x cubed using NCR notation. Okay, so let's do that. So 1 plus x all squared. So the n value is 2. Okay, so 2c, and we start with a naught, and then it'll be x to the naught, 2c1, x to the 1, 2c2, x to the power of 2. And of course, if you were writing down the final answer, you would simplify this, okay? But it just says using NCR notation, so I'm going to leave it there. If I wanted to write 1 plus x to the power of 3, okay, the n is 3, so it'll be 3c0, x to the naught, 3c1, x to the 1, 3c2, x to the 2, and the last term will be 3c3, x to the 3, okay? All right. Next one. Okay, write out the expression for the third term of the expansion of this. Okay, so the third term would be T3. And remember the sub is R plus 1, which means that R plus 1 will be equal to 3. So that'll tell me that R is equal to 2. Okay, the other thing is that n is going to be equal to 40, right? Okay, because that's what the power is there. So if I write the general expression, TR plus 1 is equal to NCR x to the R, that's the R plus 1 term. If I want to get the third term, that would be T sub 3. Okay, so let's substitute in. If n equals 40, we're going to have 40. Okay, and then it's going to be C R. R is 2. Now, instead of writing x, we're going to be careful here because it needs to be in the form 1 plus x. So I'm actually going to change that x to negative 3x. So it's going to be negative 3x. Okay, and to the power of r, and here r is 2. Okay. So if you want to simplify this, negative 3 all squared is 9. So 9 times 40c2 times x squared. So that's going to be your final answer. You can work out what 40c2 is, but I'm just going to leave it there. That would be the third term. If it asked for the coefficient, you would just remove the x squared, yes? But here it asked for term. Alright, so I'm now going to address the question, why is it that Pascal's triangle here can be written in terms of NCR? And I'm going to do it using perms and coms. I think it's important to have this understanding. Okay, explaining why the coefficients of 1 plus x to the power of n is NCR. The first thing to think about is that 1 plus x to the power of n is a product of n factors of 1 plus x. In other words, it's 1 plus x times 1 plus x, and there's n factors. Let's imagine we want to pick out the term with x to the r. What you're really doing is from these n brackets, there are n brackets, you're selecting r x's. Okay, how many ways can that be done? Well, you've got n brackets and you're selecting r x's. It's a combination because we don't care about order. Okay, it's a selection, it's not an arrangement. Okay, we're just selecting. So from the n brackets, we're selecting r x's. Now, we also select, after we've selected r of these brackets, convince yourself that r of these brackets are gone, you would have n minus r brackets left. And from each of those n minus r brackets left, we're going to fill those selections with the remaining ones. So from the n minus r brackets left, we're going to select n minus r ones. So this first guy is the NCR is the selection of x's, and then this term here, n minus rc, n minus r, is the selection of ones from the remaining brackets. Now this back term is just going to be 1, right? Because this and this is the same. Okay? So because that back bit is 1, we just get NCR. So hence the coefficient of x to the r is just NCR. Okay, I hope adding this extra bit hopefully made it a little bit clearer. This is me selecting the x's from the n brackets. This is me selecting the ones from the n minus r brackets that are left. Okay. Next, how can we go from 1 plus x to the n? We want to go to the general case of x plus y to the n. How do we do that? Okay, well, this is just one method, which involves a substitution or a replacement of x by y on x. Okay, and then what we do is we multiply both sides of the equation by x to the n. So what I'm going to do is I'm going to replace the x in the expansion of 1 plus x to the n by y on x, and then you get this thing here, and then you multiply both sides of the equation by x to the n, and you'll see why in a second, because if you follow through on the left hand side, it ends up becoming x plus y to the n. So you take this whole thing and raise it to the power of, bring that power of n to the back, and then you expand that bracket. If you expand that bracket, you can quickly see you got x plus y to the n. And here, if you multiply through the x to the n everywhere, the first one becomes x to the n. This one here is x to the n on x, which becomes x to the n minus 1. You can see the powers are going to reduce by 1. Expanding here, that's going to reduce to n minus 2 and so forth. So we get this expression which represents the expansion of x plus y to the n, and that has a special name. That's called the binomial theorem. So the expansion of x plus y to the power of n is called the binomial theorem. It's on your reference sheet, except instead of using y, they use a on the reference sheet for the back letter. Okay, so you can see x starts power of n and then decreases by 1 power, and then y, well, you can imagine y starting with power of 0 and then increasing all the way up to power of n. And the coefficients nc0, nc1, we call them binomial coefficients. Binomial coefficients are nc0 all the way up to ncn. Okay, that's just a refresher in the definition of NCR. We learnt that in Perms and Coms. The binomial theorem can be written in this shorter way, where the general term, and this is not on the reference sheet, that's worth memorizing, is NCR x to the n minus r, y to the r. Okay, next video we'll do lots of questions.